Lesson 8.3 is the converse to the Pythagorean theorem. The converse to the Pythagorean theorem just says the Pythagorean theorem in reverse. We know if we have a right triangle that c squared is equal to the sum of the leg lengths squares, a squared plus b squared. Well, the converse just states that if you have a triangle and the square of the hypotenuse is equal to the sum of the square of the leg lengths, then you know for sure that you have a right triangle. So as a quick example, let's say I have a triangle and the leg lengths are 5 and 5 root 3 and the hypotenuse length is 10. So how do I know if this is a right triangle or not? Well, I can prove it if the Pythagorean theorem works. So again, if c squared is equal to the sum of a squared plus b squared. So testing this, c is 100, c is 10, so c squared would be 10 squared, or 100, and a, let's call that the length, the side length that's 5 squared, plus, and b, let's call that 5 root 3 squared. So I've got is 100 equal to 5 squared, which is 25, plus 5 root 3 squared, which is 5 squared, or 25, times, when I square the square root of 3, I get a 3. So that's 25 times 3, or 75. And yes, it is. So therefore, I can say, and for therefore I'll use this symbol, this is, without a doubt, a right triangle. So that's application of the converse of the Pythagorean theorem, using the fact that the formula is true, the formula works to prove a right triangle. Okay, and last thing I want you to do is to memorize the 4 common Pythagorean triples. These are the 3, 4, 5 triangles, the 5, 12, 13, the 8, 15, 17, and the 7, 24, 25. Get those memorized. Those triples all represent common forms of right triangles. Let me prove it to you, and then I'll give you also multiples of those triples are right triangles. So first, 3 squared plus 4 squared is equal to 5 squared. Okay, so I can prove 9 plus 16 is 25, that this is a right triangle. So all of the multiples of 3, 4, 5 are also right triangles. So if I take the 3, the 4, and the 5 and multiply each of those by 2, I get a 6, 8, 10. That's a Pythagorean triple. That's a right triangle. And if I take each of the original 3, 4, 5 and multiply them each by 3, I get a 9, 12, 15, and so on. A 12, 16, 20, a 15, 20, 25. That's the original 3, 4, 5 with each of those multiplied by 5. So again, any form of a 3, 4, 5 combination is definitely a right triangle. Next we have the 5, 12, 13. So let's prove 5 squared plus 12 squared is 13 squared. Notice I always know that the longest side is the hypotenuse. So this is 25 plus 144 is equal to 13 squared, which is 169. And that's true, that works. So the 5, 12, 13 is one to memorize. And again, multiples of 5, 12, 13. If we were to double each of those, I would have a 10, 24, 26, and so on. Okay, the next one is an 8, 15, 17 Pythagorean triple. So if I'm going to prove that to you, 8 squared plus 15 squared equals 17 squared. This would be 64 plus 15 squared is 225. And the sum of those two is indeed 289, which is 17 squared. And again, multiples of 8, 15, 17 would have the same relationship. So like, for example, if I double each of those, a 16, 30, 34 would be a right triangle. Okay, and then the last is the 7, 24, 25 combination. So 7 squared plus 24 squared, equals 25 squared. Okay, so 7 squared is 49, and 24 squared is 576. And if I add those together, I indeed get 25 squared, which is 625. So again, multiples of 7, 24, 25 would work. So like, for example, a 14, 48, 50 would be a right triangle. So it's important to recognize these 4 basics definitely. And the other ones that will come up a lot are probably some other combinations of a 3, 4, 5, and possibly of the others. But it's to seek out, because this prevents you from having to use Pythagorean theorem. When you see one of these, you just know right away, oh, it's a right triangle, and you can start using it as such. So that's a little bit more on Pythagorean theorem and common Pythagorean triples.